Hello everybody, it's Haresh here. Today we're going to be learning about a rule that we always have to follow when solving for equations. And we call this rule balancing an equation. We want to make sure that both sides have the same thing and both sides of the equation are equal. So let's start off by thinking of something really easy, such as y, right? Let's say, for example, we have y on one side. That would mean that we would also have to have a y on the opposite side. But let's say I was to manipulate this equation right here, and I was to add a 3 in front of the y. Let's add a 3 in front of the y, but whatever I do to one side, I would have to make sure that the other side is also balanced. This is crucial when solving for equations. Let's say I was to manipulate it again. I was to take the square root of this 3y. That would mean I have to take the square root of this 3y. So this is really how we balance an equation. We're going to take the same concept and we're going to expand it on to different examples above. So let's start off with our first example, and our first example is x plus 3 is equal to 1. Well, the first thing you want to look at when you're looking at an equation is what are you exactly solving for? Well, in this case, we're solving for the x variable. So let's try and solve for this x variable. But in order to solve for x, we want to make sure that we get it by itself. And how can we get it by itself? There's only one other term in this equation that's stopping us from getting this x by itself. So how can we get rid of this positive 3? Well, I can't just cross it out like this. I would have to subtract 3 in order to zero out this term. And if this is 0, x plus anything plus 0, really it retains its value, right? The x doesn't change its value. So I subtracted 3 here, right? That would mean that this cancel out and this would be 0. Well, what we just learned about balancing an equation, that would mean I have to subtract 3 on the other side of the equal sign, so that we can balance the equation. Remember, the whole point is to balance the equation. It's a crucial step. So let's do our basic subtraction. And let's see. X minus nothing, isn't that just x? And now we have positive 3 minus x. Well, isn't that just 0? Now we have 1 minus 3. Well, 1 minus 3, isn't that just negative 2? So then now we're going to bring down this x. Well, x plus 0 is really x because it retains its value. So we're just going to write x. And then x, we're going to bring down this negative 2. So x is basically equal to negative 2. So we can check our answer by doing a formula check, right? We're going to sub in this x value that we just learned, or that we just obtained. And we're going to sub it into the x value right here. So negative 2 plus 3 is equal to 1. Well, that's true. Both sides are 1, and both sides of the equation are balanced. That means that we did an amazing job solving for this equation. So that would mean that this equation holds true. So let's try one more example where we have 2x plus 1 is equal to 13. So how are we going to solve for this x? Remember, we're solving for x here, right? How are we going to get this x by itself? So we all learned how to use BEDMAS, or you can call it PETMAS. It really doesn't matter, but I like to use BEDMAS. The B just stands for brackets. So we're going to try and use BEDMAS, but we're not essentially using BEDMAS, right? We're not trying to solve for both sides of the equal sign. So we're going to use something called SUMDUB. When we're solving for x, right, we want to use the opposite operation, and we want to use something called SUMDUB. And SUMDUB, essentially, it's BEDMAS backwards, right? BEDMAS is when we're solving for the equation as a whole, and we have all the values and all the terms. But SUMDUB, or you can call it PAMDUB, is when we have an unknown, or we have a variable, right? We're going to do the opposite operation. So in SUMDUB, the first thing that we should do is subtract. But we don't have any subtraction here. But our next thing we have to do is add. So we're going to add. We're going to start with the addition part. So how do we get 2x by itself? Well, there's a positive 1. But how can we get rid of this positive 1? We can't just subtract like that. Well, essentially we have to subtract 1 here. And whatever we do to one side, we're going to have to do to the other side. So we're going to subtract 1 here as well. So we're going to do our basic subtraction. So 2x, we're just going to bring it down. So we're going to get 2x. Positive 1 minus 1, isn't that just 0? And then 13 minus 1, well, that's 12. Now, the 0 is not going to change the value of the 2x. It's going to retain its value. Well, the next thing we can do is, how else can we get rid of this 2x? Well, we can divide by 2. And dividing is after addition. So that's where we're on the right track. So now we're going to divide by 2. But remember, whatever we do to one side, we have to do to the other side. So we're going to divide by 2 here. So now we're going to do our basic addition. Sorry, not addition, our multiplication. So 2x divided by 2, that just cancels out to x. 12 divided by 2, isn't that just 6? So now we get our x value as x equal to 6. So let's check. Let's make sure that we got the right answer. So let's sub in this x for 6. So 2 times our x value, which is 6, plus 1 is equal to 13. So let's see if this equation holds true. Well, 2 times 6, isn't that just 13? Sorry, 12. And then 12 plus 1 is equal to 13. Well, isn't 12 plus 1 just 13? So 13 is equal to 13. And that's how we know that this equation is balanced, right? 13 is equal to 13. This equation is balanced. So that's how we know that this equation holds true. So always remember that whenever you're solving for an equation, you're always looking to balance the equation. This is something that consistently has to happen. If you ever unbalance the equation won't hold true anymore. So always remember, when you're solving for equations, balance the equation every single time. So I hope you guys found this video useful and you have an amazing rest of your day.